In this video, we'll learn about the subsurface section of the Arnold Standard Surface Shader. Subsurface scattering, or SSS, simulates the effect of light entering an object and scattering beneath its surface. Not all the incoming light rays reflect from a surface. Some of it will penetrate below the surface of an illuminated object. There, it will be absorbed by the material and scattered internally. Some of the scattered light will make its way back out of the surface and becomes visible to the camera. This is known as subsurface scattering, or SSS. SSS is necessary for the realistic rendering of materials such as marble, skin, fruits, plastics, leaves, wax, and so on. Weight controls the amount of subsurface scattering in relation to other components of the shader like base, specular, or transmission. So as we increase this value, we add more and more subsurface scattering contribution to the overall shader. And now if we set the base color of the shader to something purple or blue and zero out the SSS weight, if we start increasing the SSS weight slowly, we start taking away from the base component and adding to the subsurface scattering contribution. And at 1, to keep the material energy conserving, the base color will be completely ignored. Now, if I start increasing the transmission weight, now the shader takes away from the SSS and adds to the transmission. And at transmission weight of 1, subsurface contribution will be completely ignored and its parameters will be grayed out. And all of that is to keep the shader physically plausible and energy conserving. Let's set the transmission weight back to 0. And for now, let's set the subsurface scattering radius to 1 centimeters to see the effect better. Subsurface color determines the subsurface scattering effect, or the color of the light rays when they are being scattered beneath the surface. Let's change the color to this orange color with the RGB values of 235, 132, and 67. Okay, looks nice. You start to feel the object becomes more real, more touchable the moment you add subsurface scattering and let the light scatter beneath its surface. Next, we have radius, which controls the area each subsurface scattering sample affects. Higher values will smooth the appearance of the subsurface scattering. When we increase radius, let's start increasing it by 1 centimeter increments. We allow the rays to scatter further beneath the object and therefore seeing stronger SSS effects. Increasing the radius value can radically change the appearance of the shader from looking like leather to marble. For now, let's set the color to back to its default and radius to 0.5 centimeters. You can have different radius values for R, G, and B channels. To do that, we need to disable this uniform radius checkbox. Now, for example, if I increase the radius of my R channel to 2 centimeters, we are letting the red channel to scatter deeper compared to the green and the blue channels. If you expand the color parameter, you will find a few useful presets for a few objects like apple, marble, potato, skin, and a few others. Obviously, for something like marble, if you want to have a marble texture, you would connect that marble texture to the subsurface scattering color. Now, these presets set both the color and the radius values. For now, let's use this potato preset. Next, we have scale, which scales the amount of subsurface scattering. Basically, it multiplies the SSS radius color. So by default, it's set to 1. So whatever values defined in the radius fields will be used. But if I want to multiply them by 5 at once to get a much smoother effect and let the light rays penetrate further beneath the surface, I can increase the scale value. Let's set it to 5. And now all the radius values will be multiplied by 5. Let's set it back to 1. We have subsurface scattering types, which are diffusion, random walk, and random walk version 2. Let me show you 3 renders in the picture viewer with these 3 SSS types. The first one is with diffusion, the second one is with random walk, and the third one is with random walk version 2. These are 3 mathematical algorithms to solve and simulate subsurface scattering. Diffusion is the oldest, random walk is newer and better. Random walk version 2 is the newer version of random walk, and it is more accurate compared to random walk but slower and harder to clean. The fusion method is just outdated. By default it's set to random walk. Random walk version 2 compared to random walk scatters more accurately and deeply through highly transparent optically thin objects, which produces SSS with more saturated colors around fine surface detail and heavily backlit regions of an object. But as I mentioned, it is a bit harder to get it clean and noise free. I normally use random walk version 2 as it is the most accurate method. Finally, we have anisotropy. The default is 0 for an isotropic medium, which scatters the light evenly in all directions, giving a uniform effect. Positive values bias the scattering effect forward in the direction of the light, while negative values bias the scattering backwards toward the light. So -1 is full back scatter, 1 is full forward scatter, and 0 is uniform scatter. For now, let's set it to 0. Check out the SSS samples lesson in the sampling and ray depth section of the course to learn about cleaning up subsurface scattering noise. In the previous lesson, I talked about transmission scattering. I have these few jade shaders in the scene that was created using transmission scattering. Let's apply this red jade one to our dragon. And also turn off this front light fill and turn on the front light fill for jade shader, which is a bit brighter compared to the previous light. Now, if I open up this jade shader, you see we are using transmission color, depth, scatter color, and scatter anisotropy in combination with subsurface scattering to get this advanced subsurface scattering shader, which is almost impossible to get in any other render engine. Just play with these parameters and come up with some cool shaders. So that's about the subsurface section of the standard surface shader. See you in the next one.